Hello, welcome to the course on microwave and antennas. In this lecture, we will learn about Kirchoff's voltage law and Kirchoff's current law. Now, you have to go back to your electrical engineering class and recall the Kirchoff's laws. Let us start with the Kirchoff's voltage law or KVL for the transmission line that we saw in the previous slide. Since it has RLC elements, it is a network which will be analyzed. KVL applies like this loop. Let us write the KVL equations as follows. Here if you see, this is how we start. So we have plus V of Z comma T, that is this term, and then it flows like this, I of Z comma T into R delta Z. Then we have L delta Z, this portion, and then it flows like this. So we have minus V of Z plus delta Z comma T, which is equivalent to or equal to 0. Now rearranging this equation and dividing by delta Z and taking limit to 0. So that gives us this equation. Now you may ask why we are taking limit to 0. We know that taking limit to 0 because we are making the delta Z infinitesimally small, which means the line is just like a single dot of a long line, and then you can apply this equation to any length of the line. Remember that the derivative definition is infinitesimally small or approaching 0 and not 0, because if it is 0 then it does not basically exist. So hence we are using the term approaching 0 here. And this is the final differential equation which we get from this equation. Now take the same circuit and apply the KCL or the Kirchoff's current law at the network node. KCL applies with currents, say, entering or exiting the node. So this is the node which will be considered. So if you see here, in this case, we can apply KCL at the node with one current entering and three exiting current paths. Now let us derive or write the equations based on this circuit. So if you see here, I of Z comma T, this is the entering current, and there are three paths which are exiting current paths. So those are these three paths. And now if we rearrange, divide by delta Z and take the limit to 0, similar to what we did in KVL, we arrive at this final equation. Both KVL and KCL are applicable here, since we are considering a small section of wire where the voltages are and currents are not varying. So analysis is very similar to the DC circuit.